There's some very old quizzes coming back. Sorry, that took a while. Yeah, the gray bucket, Jack. Let's put everything in the gray bucket, now I'll take that off the hall. Here's the stocking and garbage, everything go here. Just show me the negative when you're all negatives out, like Alexander mentioned that. And Jack, you want to spread out, you can just come and sit here too, so you don't have to be quite on top of each other. Müssen Dinge abgeben heute. Machen wir ja heute Montag. Ja, eben. Wir machen das ja all right. Today's the 27th. Thanks, Anton. I'm getting there, hold on. And thank you, Leo. And thanks, Isaiah. Thank you, sir. Almost missed that. Okay, there's Leo. Old Chris, but I don't see you very often, a lot of you. And this is back when we finished the nuclear power. And Christine. And I got some folks at home. Good. Hey, thank you for joining me. Hello, Hannah and Aaron. Thank you. I'll write you both down. That is super. Let me get a spot for today's date. Today being the, thank you, Jack. The 27th. It's Thursday already. Crazy. 27.5, and I've got Aaron and Hannah. So, folks, as we finish testing, welcome back. And what we're going to do today and this afternoon and tomorrow is the following. I noticed when we did electromagnetism that we've forgotten a lot of electricity stuff. I understand that, but it's so darned important. We're going to take a couple days and review it. Okay? So we're going to review electricity and its aspects, and then electric circuits as well, and how to solve those. Hopefully, we'll get to that tomorrow. So, what else? Let's see. Any announcements? No, you're not my homework, so I don't do that announcement with you. Next week, I won't see you at all, because I won't see you Monday, Thursday, or Friday. And that's just the way that's got to be. So I'll see you in 2 weeks. So alas, I will not see I will not see your folks at home. How will this work? I won't see them at all next week. So I won't see them till like 4 weeks from now. Holy smokes. And then you have your practicums then too, right? So it's going to be a while. But that's all right. We've done a lot. We've figured out electromagnetism. Let's open up our physical brains so we can remember where we're at. Okay, electromagnetism. Give me 3 things. Well, give me 1 thing. I want an electromagnetic effect. What's 1 thing that's got to be part of that? Thank you, Corsine. Jack.
Repelling.
Louder?
Repelling.
I'm sorry.
Repelling and attracting.
Yine, but you need to describe it a little different, Felix. Now, listen to my question. I have some sort of electromagnetic effect. I need 3 things to make that effect happen. What are the 3 things? So give me one of the 3 things. Leo.
Osmosis or power source.
I need a, well, okay, I need an electrical field. See what I'm saying? We're going to make it really general. Because some of those did not involve a power source. I need an electrical field. What else do I need? I got 2 other things I need. Isaac?
Magnetic field.
Okay, I need an electrical field. I need a magnetic field. And the other thing I need, the 3rd thing I need, is Devante? No, that's going to be part of what's making either the electrical or magnetic field. So electrical field, magnetic field, and the 3rd thing is, thank you, Inessa. The 3rd thing is what? Alexandra?
I don't know.
Felix, movement. Movement. Do we write that down somewhere? I hope so, because that's really, 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 really important. That's the whole basis of this unit, okay? I think we called it the Lorentz force. Did we have that phrase yet?
Yeah.
We did. Okay, so the Lorentz force, I gave you several definitions for it, but basically to get that force, you need movement, you need an electrical field and a magnetic field. Those 3 things are all at what angles to each other? Those 3 things are all at what angles to each other? 2 people know, and another, Inessa? 90 degrees. So I did it like this, and you might not have seen it at home, so I'm going to do it again. If you can make your fingers like mine for a second, just do that. So think of one of those being, I don't know which one, the magnetic field direction from north to south. The other being the electron flowing from negative to positive, and the 3rd is the direction of the movement. And so those 3 things, they call it the right-hand rule. You don't have to memorize it, but just be aware that it's out there if you ever need it. This is how physicists figure out which way things are flowing due to an electromagnetic effect. Either the generator effect, or what was the other one we did where something went around? Generator effect or Devante? The motor effect, thank you. Yeah? Okay, I got some other folks at home. And I got Ethan. Hello, Ethan. Super. Thanks for joining us, all 3 of you. And Aaron reminds me, practicum is June 14th through the 25th. You probably knew that, but make sure it's in your calendar for future reference. All right, are we ready? Let's do it. Okay, electricity. I'm trying to do this so my folks here at home can see this pretty well too. Has 3 qualities. You might say, Mr. Rice, what are you talking about with quality? Well, I'm not sure how else to describe it. Three things we can measure about electricity. What's one? Isaac, see if you follow me.
The voltage.
The voltage. Let's start with that. That's actually, I find, to be the hardest one for us to understand. Okay? Voltage is more or less like the change in energy of the electrons. Are they changing from a really big negative to a big positive? Are they going from a little negative to a little positive? So it could be like this. Wah, going to wah. It's my little electron. This would be, those are supposed to be the same size. I'm still sleeping here. That's supposed to be high voltage. And wah, going to wah. That would be low voltage. If you're okay in math, you might want to think of this in like a math way. Think of a high voltage being like from a minus 100 charge to a plus 100 charge. Think of low voltage being like a minus 2 charge to a plus 2 charge. There's less to push the what through the little wire. Less to push the through the wire. Devante. Yeah, good. I put a little star about here. I could write the word here. Here. Less energy to push electrons through the wire. Another analogy, and I don't think I did it with you this year, is like a waterfall. A waterfall. Like if you've been anywhere in the mountains, you could have a really short waterfall, right, from here to here. Okay. That height of that waterfall is a bit like voltage. Or it can have a really high waterfall. Then it's got like a high voltage. So the height of the waterfall is a bit like voltage. Sure folks at home can see that, or if you have any questions. Ethan, you are present. I see you. Thank you. Good, then we're 1/3 of the way there. There's 2 more. So voltage, what's another thing we can measure about electricity? 1 people, 2 people know? Corsine? Power and what? Power is not really one of the 3. Power is important, but it's like applied. It's like I take a couple of the others and join them. So I got a more basic one. Jack? Why? No, wattage you just said. That's power. That's power. Alessandro?
Current.
Current. Current is for most students a little more straightforward. That's the amount of what? What is current? Isaiah, if I got a high current, I got a high amount of what? Moving along. So what's moving? A lot more what? If it's high current. Amps? Amps are not things. Amps is a measurement. I want something that's actually physically moving. That's electrons. Electrons. So current is the amount of electrons moving. Maybe I should say flowing. A little more graceful. In the lead or in the wire. If you like my water analogy, think of that as like the amount of water. So I can have a waterfall and I can have a little bit of water flowing. That would be a low current. Or I can have a high amount of water flowing. It doesn't affect the height of the thing, that's the voltage. But the amount of water flowing, we also call it current, don't we, for water? That's another way to think of it. Okay? More electrons, more current. And as we talked about, we need a lot of current at home, don't we? We use a lot of current for different things. Can somebody give me a device at home that probably takes a lot of current? Something at home. You know something? A little louder? The refrigerator. Yeah, that takes a fair amount of current. It's not always on, by the way. Sometimes you'll hear it and the pump goes on, and that's when it's using its electricity. Other times it's just kind of insulated and just sitting there. Yeah, sporadically it uses a lot of current. Some other things at home that are fairly current intensive, Jack. Computer, it varies on the computer. Some use a lot, and others, like a tablet or something, aren't really using much. Kind of depends. Felix?
Water boiler.
Yeah. Cooking water, boiling water, it takes a lot of energy. That's very energy intense. Like even when you take a shower, somewhere in your apartment, there has to be a water that then's got to be heated up again. That takes a lot of energy. Devontae?
Microwave.
Microwave, yeah. Yeah, that has a fair amount of energy use, especially if you have a big chunk of frozen whatever in there. And Don?
Electric stove.
Electric stove, yeah, exactly. And Leo?
Yeah, hair dryer.
Hair dryers take a lot of current, right? Good, Leo. Yeah. Toasters too. Toasters take a lot. Let's see if I had any ideas at home. The lights, some of them do. If I add them all together, Ethan, but individual lights may not be that much. Especially if I have like a Sparlampe, right? One of those in, then they're not as bad as they used to be. But good. Thanks for participating, everybody. Let's go on. Let's talk about our third item, which I'm going to review because you may not have had it since last year. Voltage, current, and Felix, do you know it? Resistance, you got it. Pretend you're in an S-Bahn and you're walking through, trying to get to the other end of it. There's always people in your way. What do you got to do? You got to squeeze through. Now, the electron's going through a wire. There's one right here. What's also in that wire that they got to go through? It's not like empty in there, so there's not only electrons. What else is in there? If I could cut it open and look at it. Anton? Yeah, atoms, probably of what stuff, if it's your typical cable. What are a lot of them made of inside the plastic? You know what I'm saying? Copper, right, it's a good insulator. So we got atoms of copper, right? So atoms is right there, Anton. And imagine the electrons are trying to get through all those atoms, right? They're kind of moving and trying to get through. There's a lot of what starts with FR as a friction word. Look at that. All right, so there's friction, right? Okay. Hate it when I do that. Yeah, so that's kind of what resistance is about. So as the electrons flow, there's friction in the wire. Okay? What would make it more friction? Use my S-bond. What could I change in the S-bond to have more friction? What could have more friction in the S-bond? Use my analogy, Leo.
Well, add more people.
Add more people.
More atoms.
There you go. So I got more and more atoms in there, so there's a lot of friction. Good. Anything else I could do? What's it? Yeah. Yeah. True. True.
Make the S-bond or the cable smaller.
Well, let's not jump back and forth. I could make the S-bond, if I wanted more resistance, I could make the car longer. You know what I mean? So now instead of walking through 10 meters, I got to walk through 30 meters or whatever. I got a long way to go, so it ends up being more friction. Okay, but you got the idea. Okay, so friction is the resistance in a wire or lead as the electrons flow through atoms. Have a low resistance. Have a high resistance. These are terms you know, but you may not have thought it like this for a little bit. So what sorts of items have a low resistance and what sort of items have a high resistance? Let's see if anybody at home is responding. Not yet. I'll go to Isaac here.
Like conductors.
Conductors, which one would that be?
lower.
Yeah, so if it's a conductor like, turn your phone off, please. If it's a conductor like Devante said, oh, that's a corona test, okay, thanks, Christine. Just show it to me, you're a negative person, thank you very much. Okay, hold on, I got another couple corona tests. Corona commercial, okay, Corsine I got, so we're just putting it all in the gray bucket there. And you got one too, Felix? Thank you. Anybody else? I haven't seen your corona yet. Isaac, thank you. Did I see yours later? Did I see yours already? Oh, I already marked it down. I got an extra line in here. And Devante? What a nice group of negative students. Thank you so much. I love it. Remember before negative was something positive? Never mind. Okay. Okay, high insulators, exactly. Insulators, and that would be the other one. You got it. So low resistance, conductors, and Ethan has the other one as well. So he said insulators. I can spell it, insulators. Have a high resistance, okay? Low resistance, we could say like metals. Give me something that's got a high resistance. What could I make an insulator out of? And there's more than one type of material. An insulator could be made out of Inessa. Plastic is a good insulator. In fact, that's what I have around my wire for my cable, type of plastic, don't I?
Negative rubber.
Rubber, yep. What else do they use for insulators? Probably a couple more things, you might know. Isaac?
Or like fur or wool, that count.
It was, but it'd be unusual. And fur and wool also, we use it to charge up something, like in our lab. So I probably wouldn't use that as an insulator. Anton? Glass, yeah. Let's see if they got any guesses at home. Yeah, Ethan's got one too. Wood. Wood is a good insulator. And ironically, another one is air. Air doesn't really conduct current so well. So air can be itself a good insulator. Here's an interesting thing, all right? Maybe you know this already. Your skin is a good insulator electrically, which is probably good, isn't it? Because if lightning struck or anything, odds are better that you would survive. It's got about, oh, we don't have the unit yet. Okay, I'll tell you about that in a second. We need to do our units now. Make sure these folks over here can see. Question for Isaac, yeah? You know the next one. Okay, let me set up a little table, and then Isaac, you can help me out. You're one step ahead of me here. I'm moving slow because I want to bring everybody else with me. Yeah, exactly. Right. Rubber, wood, plastic, all correct. Good. Okay, so what did I call it? Quality? Quality. Quality. Label, or in German, Einheit. And in English or German, the symbol. And then we actually have one more, which is the variable. And that's in equations, which we're going to use too. By golly. Okay, so the three qualities, I'll just put them in order, right? We talked about voltage. We talked about current. And resistance. So let me get out of your way. Folks at home too, let's try and set up a table like that. So the qualities are the three we talked about: voltage, current, and resistance. We're going to make a table with what label you put on it, and what symbol and what variable, like a math variable, we put in. And let me let you catch up first, so you have that already, and we can take some answers from folks at home too. So thanks everybody at home for participating. Okay, good. All right, Isaac, give me one, what do you want to give me? One of the labels or what were you thinking of? Just give me a label for one of them.
I'm pretty sure voltage is volt.
Oh, yeah.
Did you prepare it too? Or?
Now, let me get a bunch of folks. Okay, so that's what I mean. So voltage is measured, not surprisingly, in volts. Let's get some more. Folks at home, you got any? Aaron, Ethan's got a letter for voltage. And that's the variable V. And the symbol is also V. So I'll put that, Ethan, in two spots. So we're pretty good on voltage. Start me off with a number. Another. Alessandra, what do you think? Either of these puppies?
I for variable equation squared.
Yeah, well, that's a tough one. I'm glad you knew that. So ironically, I is the letter we have to use for that. How about, since it's I, over to Isaiah. For current, the amount of electrons, we measure in what sort of thing? Yeah, but then if a bunch are flowing, we say we got a lot of current. So the item we measure current in, because we don't usually say number of electrons. Amps, ampere. Yeah, exactly. And the symbol that I put on things is an SO. Let's see if some folks at home had that as well. And Aaron, that's probably not the symbol for any of them as far as I know. But let's try the third one, folks at home too. Resistance, see if you can pull anything out of your head from last year. I know I didn't teach it to you, so let's see if there's any memory of that. Felix, you got something for resistance?
It was O,
Yeah, for the what?
the resistance.
Yeah, for which thing?
Oh, what is the label?
The label, yeah. If I heard you right.
Yeah,
So,
and then
ohms.
it just looked like this Greek thing.
Yeah, it's a Greek thing. What's the Greek letter somebody else said it's in, Leo?
Omega?
Omega.
Omega.
Looks like a horseshoe. And the variable, if it's in an equation, what's the variable, the letter we use for resistance? Inessa? R. You are correct. Okay, so how many of you does all of that look sort of vaguely familiar from last year now that you've seen it again? Okay, all right. Good. Let me erase a bit. So I got room up here again. Folks at home, I hope you can see it all right. I hope with your teacher last year you did some circuit diagrams, and I want to remind ourselves of what the symbols were for that. So circuit diagrams. First, let's talk about like the item, and then the symbol. And then we'll draw a simple circuit as well. Okay, so item and symbol circuit diagram. So you're looking at one, and why don't I go ahead and start? If I got this symbol, just a line, that could represent a what in a circuit diagram?
A wire.
Uh,
A wire. Wide.
Wire, good, or lead. So lead or wire, thank you, Isaac. Lead. Or wire. So it's just a plain old line? Yeah, exactly. Aaron knew that too, good. Yeah, last hour too. Yeah, also eighth period, right? What else? Do you remember any other things now, Vanessa? Yeah. Good. Okay, so for the battery, or sometimes called the power source, which I use a lot of this year, right? So let's do what Vanessa said. So a power, long line, short line, and then normally you want to just put the electricity going out each side, like that. Which line was which charge? We got to put little plus or minuses over the top. Which one? Anton?
I think the minus is the small one.
Yeah. So that's how we put it. Yeah, just do it. Well, yeah, that's fine. Good, so there's our power source. Battery or plugged-in power source. Any other stuff you might find in a circuit that you recall, Devontae?
So this is what for the ammeter
Yeah,
is circle.
and Devontae remembers the name correctly too. It seems like it ought to be called an ammeter, but it's not. It's an English and German, an ammeter. And the symbol he's described correctly is just a circle with an A in it. All right. In addition to ammeters, we also have heat meters that help to measure stuff. Felix,
Voltmeters?
yep. And that's a circle with a V. Right. Got at least two more things I can think of. What else is in that circuit? Percy?
Light bulb?
Yeah.
I don't remember the symbol, but I think it was a circle of the accident.
Yeah. Now, it can be a light bulb, or it turns out it could represent anything that consumes electricity. Refrigerator, laptop, whatever it is. So we're going to call it also a consumer. And you're right about the symbol as well. So circle with an X in it. Super. You guys remember that pretty well. And we knew that as well. Ammeters and voltmeters, Ethan had good. One last thing, although I might have forgotten something that I can think of, and maybe you know, two people know. Let's see, Devontae, what is it? Resistor. You know, there's two things I forgot. I forgot that entirely. Resistor. Do you remember what it looks like? Can you draw it in the air, Devontae? Exactly. The resistor, and we'll learn more about those or review if you've had it already, is some number of zigzags, as Devontae threw in the air. And I got maybe one last thing that's typically in a lot of circuits, real ones at home too. Anton, you remember?
Switch.
Yeah, switch. In German, exactly. Okay, what's the switch symbol look like? And maybe we draw it in the air. Alexander, what's a switch look like? Yeah, okay, all right. Draw a switch in the air for me. Okay, what is it, Leo?
Like a rectangle.
No, that's not really a rectangle. It's gonna look more like, what, Devontae? Line going across, okay? Yeah, good. Now, some teachers want little dots and stuff. I don't really care about the dots. I'm never really sure what the dots, why they have to be there. But you want an opening, right? And that would be like, we would say an open switch, that would be like the lights off in this room. And then when I hit the switch, I close it. So this is open right here. Open switch. So no electricity is flowing, of course. Huge. Very good. Didn't know how far we'd get. We're getting pretty far. Questions so far? All coming back? Okay. Let's try and get you drawing some stuff. All right, if you can't do some of these, do as much as you can. And if you do finish ABC, then mark the current direction. And okay, let me read those off. So folks at home can do this too, just on scratch paper. If you want to do it in pencil, if you're worried about making a mistake, fine, whatever you want to do. But let's try 3 diagrams. So I'm going to give you a couple minutes to do it. Do a simple circuit with 1 consumer. Do a simple circuit, well, it won't be as simple. A circuit with a switch and 2 consumers. And then if you remember what series is, let's try and do a circuit with 3 resistors in a series. And then last thing, see if you can remember how to mark the direction of the current in each one of those, A, B, and C. So let's have you guys put some of those on the board, but for now, let's have you try all A through D. I'll give you about 5 minutes to sketch them. Good. Folks at home can try and sketch those too. A lot of you still remember how to do this, which is great. Who are your teachers some of you last year? Who do you have like electricity with? Ed Westman, great. Anybody else? Or you all Ed Westman? Mr. Bala, okay. Yeah, Jasmine. So we were kind of mixed up last year. All right, okay. Well, they did a good job, it looks like. And a lot of you are doing a good job too, so let's see if we want to have three some of these. Yeah, super. Yeah, all 3 of you. Yeah. Nice. Yeah. First one. Yeah. Now don't forget your power source. You're going to need one voice for each one. Otherwise, otherwise it won't be circular. I put it in. Exactly. Start. Each direction. So try and do D if you got this far. So try and put in the directions. You're already through. Remember how to do that. Yeah, directions. Don't forget your power source. Just follow it around. No. Try the first time. That's coming from a negative. That's the source of your. Okay, let's go on up there. So how about A? B. Sure. C. Okay, thanks everybody for doing that. Let's check it out. All right, here we go. So for the first one, looking good. Just make sure your line doesn't come inside there. That's good. And then to make it nice and crisp, so you're getting that touch there. That. Other than that, looks good. Let's go to B. B, we still need something. What do I need to put? Alexandra, what's missing for B? Yeah, so we still need to put that on there. And on C too, right? So we do have to do that. It's just part of the electrical drawings and physics. Other than that, we got what? A switch and two consumers? Good. That looks fine. And for the last one, we got three resistors. We got a consumer too, but you don't have to have a consumer in there, but okay, that's fine. No big deal. Let's put some directions. So remind me, how about Devante? What do I do for directions? They go from where to where? You got it. So let's do that. And the same with the next one. If it were closed, And the last one also negative to positive. If you drew it the other way, it doesn't matter. I mean, the exactly opposite, as long as you go negative pole to positive pole. You, questions from you? We're doing swell. We're gonna just keep moseying, unless I got any questions from folks at home. Maybe they can't see that. Yeah, the plus and minus, right. Ethan noticed that too. Direction is to the left. Yeah, that's right. Thanks, Ethan. Good. Good participation there. And folks at home can check those as well. Keen. Keen. Is that right? Oh, the clock is wrong in here.
Yeah.
Oh, I wish you had told me that. That's actually all right. That's really not a bad place to stop. So I'll see you this afternoon, everybody, folks at home too, 8th period. And we'll work on the other part of this, solving a circuit this afternoon. So, see you then. Thanks, you three. Good participation. See you 8th period. Bye.